Why does a single photon or a single electron, fired one by one, still building a clean interference pattern in a double-slit experiment? In the energy filament theory, the wave is not the particle's own substance spreading out. The wave is responding to the environment. Because motion in an energy sea stirs a local ripple map that later guides probabilities. Here's the strange part we all agree on: every shot lands as one dot, like a grain of sand hitting a wall. But after enough dots, a striped interference pattern grows by itself. And it's not only light or electrons, even single atoms and molecules can do it. Then the moment you try to measure which path it took, the stripes vanish. Textbooks often tell you the particle is a wave until you look. In this picture, the particle is never a foggy wave object, the medium is. Recall the earlier episodes. Light is an open relay, a short twisted wave packet handed forward by the sea. Not a little marble flying through emptiness. A basic particle is a closed relay, a filament ring stabilized by circulation, not a mathematical point. Atoms and molecules are clusters of those rings, still patterns of relays and locks. So light and matter share a root. Relay. One is an open relay that travels outward. One is a closed relay that cycles on itself. Once you see that, the double-slit puzzle changes. If both light and particles are fundamentally relative structures, why do both display the same wave like interference statistics? Because the waviness is a third party. It is the sea's ripple map, not the object's substance. You can picture it like water and two gates. Put two slits in a barrier, and a disturbance passing by will create two overlapping ripple sources. The surface will develop a striped pattern of high and low response. In this picture, when a relay packet or a ring structure moves through the energy sea and encounters the two-slit geometry, the sea around both pads develops overlapping local oscillation patterns. A standing terrain made of phase and tension. It's an invisible probability map. Where the map is more in step and lower cost, rivals are more likely. Where the map is more awkward and higher cost, rivals are less likely. Project that preference onto the screen, and you read it as bright and dark fringes. So the stripes are not the particles being a literal wave spread through both slits as a substance. The stripes are the media's interference pattern acting like a guidance landscape. Each particle still lands as one dot. And in this view, each particle still takes one actual path in a given run. But which slit it takes, and where it ends up, is biased by the ripple map built by the environment and the geometry. One sentence summary. Motion creates a rip terrain, and the ripple terrain guides the probability of outcomes. Now the measurement kills interference step becomes less mystical. If you want what path information, you have to put a marker into the setup. In this picture, that marker is like hammering stakes into soft ground to track footprints. You don't get the track without disturbing the ground. The moment you insert a measurement interaction strong enough to label the path, you alter the local sea patterns, you break the clean overlap between the two channel maps. The ripple terrain stops being a coherent superposition, so the interference fringes fade out. No magic switch, just a map you damaged by trying to read it. Even entanglement becomes more intuitive in this language. When one photon splits into two entangled photons, they carry a shared rule set for how they imprint and respond to local sea patterns. Like two teams given the same rhythm sheet, separated far apart, they don't need to send messages to behave consistently. Each one generates and reads its own local rip terrain using the same internal rules. So correlated outcomes can appear without a literal signal racing between them. The punchline is simple: lights and particles are one family of relay structures, open and closed. The wave-like statistics are one family too, and they come from the environment. Next episode we take this into a sharper test. If the rip map is real media behavior, what changes when the sea state changes? Near extreme regions like black holes, near the cosmic boundary, or near a silent cavity? Tap follow, share it on New Physics, Clear Universe.